What's going on YouTube? Today we're going to discuss the latest or go over the latest Splunk room in TryHackMe. After this room we will move on and do other things other than Splunk, I'm gonna promise you. So basically today we're going to use Splunk to investigate the ransomware activity. And as you can see here we have only one task. Let's go over the description. Scenario: you are a SOC analyst, Security Information Center analyst for an MSSP, managed security service provider company called TryHackMe. A customer sent an email asking for an analyst to investigate the events that occurred on Keegan's machine on Monday, 16 May 2022. So the client noted that the machine is operational, it's working normally, but some files have a weird file extension. So basically the machine is working normally, the ransomware activity is partial in the machine. So the machine is not locked up, okay? Because most of the time when a ransomware infects a machine, it locks the entire machine. You cannot access any file, the entire file system. But in this scenario we have today, the client noted the machine is operational, but some files have weird file extension, means it has been encrypted. The client is worried that there was a ransomware attempt on Keegan's device. Your manager has tasked you to check the events in Splunk to determine what occurred on Keegan's device. Happy hunting. So, before moving on and analyzing the events in Splunk, it's harmless to say that the ransomware may have infiltrated the machine or Keegan's machine specifically, either through direct download or through a compromise. So machine might have been compromised first, and then the ransomware payload has been downloaded further to the machine to encrypt some files. Let's see exactly what happened. So we go to Splunk here, we select all time, and since we don't have an index here for the data, we're gonna choose star, indicating retrieve all of the data that has been ingested into Splunk. So we have around 17,078 events, okay, with different source types. So we have from sysmon, we have other sources, we have event logs from Windows. Okay, so what we require to find out here. Now, we want to find out the source of the infection, okay, the files, the artifacts, and if any, we need to point down all of the C2 servers. So typically that's what we do when we investigate an event, right? So let's see, we have these interesting fields. Computer name, we have 2 computers, and if we scroll down we also have 191 more fields. Let's take a look at these fields and mark the fields that we may need. So let's see here. So we have destination IP, might be useful. Destination port, again, might be useful. Details, event code, file path, image, key name, key type, keywords, message might be helpful. Original file name, process name, query name, query results, signature. We don't need the signature because we don't have IDS alerts, so we're gonna skip this. Source IP, source port, target file name, target image. All these may be useful. User as well. Okay, so let's take a look. We have 86 event codes. Yeah. File path. Good. Process names, 13 processes. These are system processes. And log in, log out. Okay. We have one source IP indicating the machine that we are investigating. Source port. Okay. And let's take a look at the destination IPs. So as you can see, destination IPs, we have two IP addresses hitting the most events. Destination port, we have 443, 80, and 445. So as you can see, we can have a clue on the activity we are investigating. Mainly, we are investigating network connections here in the machine, specifically the network connections happening over protocol HTTPS, HTTP as well. And we have one event 445. We're not gonna take a look at this. So we have 4 events HTTP, 296 events for HTTPS. So it means the machine, the source machine we are investigating, has been downloading stuff from the internet, retrieving stuff from the internet, and vice versa. So if we click on 443 here, let's just to have an idea, and we click on destination IP. So these all of the IP addresses the machine was contacting, right? And we have this IP address. Probably this is the IP address of the attacker, or the C2 server, let me say. It might be, I'm not sure. We're not sure yet of anything, but we're just discussing the numbers, and we're discussing the items we have here. So 206 on this IP address, and this destination IP. The source IP is still 1, which is the machine's IP address. And as you see, guys, if we go back to destination IP, we cannot see the machine's IP address in the list, which means the machine doesn't run any web server. All of these are destinations the machine is or has been witnessed to visit to retrieve files whatsoever. So the ransomware has been retrieved from one of these IP addresses. Okay, specifically this IP address. If we click on that IP address, as you can see here, we have 206 events, and we can see there is an executable called outstanding gutter under the temp directory. So this seems fishy as well. Okay, all right. So let's go here and find the questions. A suspicious binary was downloaded to the endpoint. What was the name of the binary? Now, you might be tempting to say that it's very clear that the binary here is the binary, or the binary that has been downloaded from this IP address. Okay, and that could be the case, but in real scenarios, you cannot just guess. Okay, we need to make or base our conclusions on evidence. So basically, if we go back here to the very start, okay, and if you go back to the question, as you can see, the question states that the binary was downloaded. So it has been downloaded either through port 443 or port 80. In port 80 we have 4 events. In over port 443 we have 296 events. So the way to go is we can go to 443, okay, and yeah, we see a weird binary name, but we cannot just right off the bat conclude that this is the binary we're looking for. We have to find more clues. So if we scroll down, protocol TCP, as you can see, not HTTPS. Scrolling more, we have only these. Source IP image. So in the image we have, as you can see, 3 paths involved. We have the one under temp, we have the Windows Defender, and we have OneDrive. Okay, now as you can see, we have only 3 executables when it comes to port 443. What about port 80? If we go to port 80 here, highlight port 80, see what are the executables involved under this. We have one, which is PowerShell. So we have PowerShell here. So let's go ahead and click on PowerShell. We want to find out how this weird executable was retrieved to just make the right conclusion. Show 33 lines. So PowerShell was used to connect over port 80 to destination server. We just don't know the command that was used. Okay, so right now if we go back and write PowerShell here, we have 281 events involved with PowerShell. Let's take a look at this. Okay, so if we go back to the interesting fields here and highlight, if you can see more fields that will indicate the command used. As you can see, we have 34 fields. If we select command line and description might be good. Do we have parent command line? Parent command line, yes, we have one. Parent image. Okay, so let's see now what was the reason PowerShell was used over port 80. So if you go to command line, we see 13 command lines, and one seems a bit fishy again. So we have PowerShell used, and we have the space 64 string. If we click on that and we highlight the base 64 string, go to cyber chief. Let's close this one. So from page 64, and let's decode the text to a suitable format. Let's select UTF. Okay, let's see. That's the PowerShell command used. Set preference, disable real-time monitoring, wget, and we have this IP address, not IP, destination domain /outstanding gutter. So our instincts about this file were correct. Really, it turned out that this file is really suspicious and out of place. And it was retrieved from this destination and stored under the temp directory. So what it does, as you can see, after the download of the file, scheduled task was created to execute the outstanding gutter executable with elevated privileges, as you can see. So create the task and run the task. Okay, so we have many things to answer here. So first, as you can see, this is the weird executable name or the weird executable file retrieved from this destination. Okay, the executable was scheduled to run as system using scheduled tasks. Most probably this is the ransomware, or it could be the executable that will retrieve the ransomware. We will find out later. So if we go back here, answer the questions, the executable name, and this is the domain name or the destination from which it was downloaded after we define the URL. So basically, if you define the URL, we go to defang. It's easy actually. Let's copy that. And yeah, let's write a new recipe here. So this is defang formed. What Windows executable was used to download the suspicious binary? Enter the full path. We know that, guys. It was PowerShell. How do we know? We just know. You know, it's PowerShell, as you can see. But the full path for the PowerShell, you can find it by going back here and selecting image. In the image, it displays the full path of the PowerShell. Parent image, maybe. Yes. So what command was executed to configure the suspicious binary to run with elevated privileges? So we already answered this, guys, when we decoded the base 64 string. Let's go back. take this again. Decode base 64 okay, so that's the command used to create schedule task, and that's command used to run the binary. So answer the questions. What command was executed to configure the suspicious binary to run with elevated privileges? There you go. And what permissions will the suspicious binary run as? What was the command to run the binary with elevated privileges? Now, what was the user? The user can be found from here. It's system, but the correct format is NT authority system followed by semicolon and the command used to run the binary, which was this. See Windows, that's the command. You can find the answers from only the base 64 string. The suspicious binary connected to a remote server. What address did it connect to? Add HTTP to your answer. So that's suspicious binary, guys. It connected to a destination server. Let's find out. So now we take the name of the binary and we search the logs with this binary. Let's see. Okay, so we want to find out what was the destination server the binary connected to after it was downloaded. So we can find out through command line maybe. So nothing in here. Let's take a look at parent command line. We have the partial command and we have the executable itself. Image. Okay, destination IPs. Again, we have this IP address which has the most hits. Do we have more fields? 31 more fields. Let's see here. Okay, current directory, event type, hashes, process ID. Nope. Okay, let's see here. What is the domain or the destination that the server that the executable connected to? So apparently here, if we click on ports, we have one destination port 443 over which the executable connected to its destination server. So if you click on that again, we have 291 events. Let's go over these. So indeed, as you can see, we scroll down. This is the executable, the process ID, it launched, and the destination IP it connected to. But we cannot see any clue about the domain it connected to. The same with this. Okay, let's go back to the filters. Maybe some extra filters would help us out finding something. Let's see here. Destination, keywords, record number. Nothing in the messages, users, system, and not translated. Event code is 3. Did we filter by destination IP? Let's filter by destination IPs. Still, we don't have a clue about extract new fields. No, we have to go back. There were more extra fields shown here, but I cannot see them anymore. Let's go back. and filter only with the executable name, maybe we'll have broader perspective on the fields. So command line, nothing from here. Details, again. Query name. This is interesting. If we click on query name here, we get 5 events. And let's take a look at one of the events. So the user not translated. Query name. As you can see, it looks part of the main C2 server, or the domain name from which the original binary was retrieved. So this is domain here, as you can see, ends with ngrok.io, and it has another extension here, or subdomain, from which, or to which, the executable connected to after it has been downloaded. So to answer the question, the suspicious binary connected to a remote server, what address did it connect to? This is the address. It becomes clear now through the query name. And note, guys, that the query name can be, or can only be found if you investigate the sysmon logs. These are not Windows event logs. So to answer, just do defang on the URL. Take this and go to defang, remove this, and there you go. A partial script was downloaded to the same location as the suspicious binary. What was the name of the file? So basically, this file was downloaded, and then it has downloaded another file. The other file is partial script. Probably the partial script is the script that actually has encrypted the files on the system. So that was not the ransomware, although it might be classified as a facilitator to the ransomware. So basically, let's see here. So I have a partial script downloaded to the same location as the file. The file is located under the temp directory. So if we want to search for the partial script, what we can do, we can make our life easier by typing .ps1, the extension of the partial. By doing that, we look for all of the partial scripts in the events. So we have around 36 events. Okay. Now, to make things easier, we have to look in the same directory under which the file was stored. If we click on image, we can't see anything. Let's see if there's a field for directory. Nothing. We don't have. Target file name. Under target file name, we see many scripts under the temp directory. Are these the, or one is one of these scripts is the partial script that has been downloaded? Could be, but we cannot answer right away. We have to use the filters. So .ps1, and then we have to write the path. So let's copy this. Unbalanced quotes. What if we used escape the double quotes? 0. How about this? 0 events. Okay, let's go back. Go back to file name or target file name. And maybe we can sort these under a table. So if we go here, use table, and then target file name. Of course, we have to use dedup. Let's see all of the partial scripts in the event logs. So we have script.ps1 under temp. We also have these partial scripts. So how do we know which one is the one that has been retrieved by the executable outstanding gutter? Let's click on this one and investigate the related events. So if we go back and investigate this, show all 25 lines. So target file name, image. So as you can see, this PowerShell script has been downloaded through PowerShell, which actually narrows down the suspicions. If we investigate other files, maybe this script here, let's take a look. Again by PowerShell, target file name, rule name, task category, file delete archived. What was the category on this event? Task category, file delete archived. So they have the same category, but the names are kind of indicative of the nature of these files. We still have, the answer can be script.ps1, and it is actually, but there are more clues that can help us make sure that this is really the answer to the question, or this is the script that has been downloaded by the executable. But we have to find out somehow. So if you look at the message, all of the messages carry file delete archived. So if we have to link or find the link between this, okay, and the executable outstanding gutter, we may have to search for script.ps1, okay, and with the file name outstanding gutter, see if there's any connection between them. So we cannot see the connection. We want to find out what was the command. If we go back and again to the query name, what was the query name, query status, query name. So from here we have 5 events. Maybe through these 5 events we will be able to find out what was the command to retrieve this PowerShell or download this PowerShell script. Do we have command line here? So still we don't have a clue, or we don't have the link between this executable and the script. We want to find that link to make sure that we got the right file, right? Okay, let's expand this one. So it's DNS query to this address. Where was it? The query name sometimes gets me. Okay, so query name to this address. What we can do here, this is the image, okay, the file name that issued the query, but still we can't find out if there is a target file or path. We still are not able to find the link between them, and maybe we will not be able to find the link. Query results, let's see here. So there are no sufficient information, guys, to link between the outstanding gutter and the PowerShell script that we saw. Okay, so the description says a PowerShell script was downloaded to the same location as the suspicious binary. We are making the guess that outstanding binary here, this binary has retrieved the script to the same location, but we still cannot find how it was done. Let's go back, command line, So most probably when it was configured to run as system here, okay, this is where, as you can see, this one, schedule task, run tn outstanding cutter. If you click on this one, investigate the events, the parent image. So PowerShell retrieved the file, and now the file is running as a scheduled task. But we still don't know, guys, the link between this file and the script. All we know that the file is running as scheduled task and connecting to this source. And then out of the blue, we see a script downloaded to the same location. So if we go back and type PS1, all right. If we go to target file name, again, sort them, dedup, target file name, table, target file name. Let's go over these files. So all of these are PowerShell scripts under the same directory, temp. Although the names of these scripts don't suggest that they are malicious, but they could be. They could be in real scenarios. So in real scenarios, we really have to find out the link between why we suggested that this script is linked to the suspicious binary here. It is linked actually. These are not suspicious binaries, but in real life they could be, because the attackers could fool us by using familiar names of their scripts. So, but for now, this is the script, judging by the other names of the other scripts. The malicious script was flagged as malicious. What do you think was the actual name of the script? So basically, after the script here was downloaded, it was flagged as malicious. Okay. So to find out how, let's go back and we can grab the ND5 hash. By grabbing the ND5 hash, we can find out the real name of the script by using, of course, VirusTotal. So file hashes, IP addresses, domain names are all indicators of compromise we can use online to research the threat. We go to details and we see the names suggested for this PowerShell script. The real name is Black Sun. That was the real name based on the hash. But the attacker used different name, script.ps1, maybe to somewhat hide it. But still, again, even though they use different name for the malicious script, the attacker couldn't hide the script well by not blending the name of the script with other names. So if I was the attacker, I would not use the name script. I would name the script to be somewhat similar to these not malicious scripts, so that it would easily slip off the investigator's eyes. So that was the answer. A ransomware note was saved to disk, which can serve as indicators of compromise. What's the full path to which the ransom note was saved? Let me make sure I am still recording, guys. I am recording, yes. So what's the full path to which the ransom note was saved? So here, after uncovering the full scene here, guys, we now know that the malicious binary here was used to retrieve the PowerShell script that was responsible for encrypting the files. Now we want to find out what the attacker wanted in the first place. We want to look for a ransomware note. To look for the ransomware note, we can use .text as the file extension, because the ransomware notes are normally stored as text files. So we look for all the text files, or all the files that have the text extension. And we have three events. We have three notes, one under the downloads, one under the temp directory, and one under temp directory. Probably our file is this one. So write the full path, that's the full path here. And the last question, the script saved an image file to disk. to replace the user's desktop wallpaper, which can also serve as an indicator of compromise. What's the full path of the image? So basically, when the ransomware is downloaded to your system, they replace your desktop background or wallpaper with a different image. Find out that image. So how to find out the image? We can search for image files. So we start with maybe PNG, and maybe you start with WebP. You can also use, but in this case it is JPG. And as you can see, we have two events from which we have the directory. And that concludes the challenge for today, guys. I hope you find that helpful. And if you want a well-rounded document for all of the notes we have on Splunk, you can still subscribe to the channel membership and maybe retrieve these notes. So if you go to Splunk, where's Splunk notes? Splunk notes. Okay, so these are operational notes, okay, to guide you how to investigate the logs, starting from investigating IDS logs, how to investigate HTTP traffic, extracting artifacts from different sources. Okay guys, so that was the last challenge about Splunk. Okay, in the next upcoming videos we will take up something different, so I will see you later.